Hello students, so in this video I am going to explain how to solve an assignment problem using Hungarian method. So this is an assignment problem, as you can see here. 1, 2, 3, 4, these are assignees. Assignees means person who are going to do the job. There are 4 people, person 1, person 2, person 3, person 4 who are going to do the jobs, and there are 4 jobs: job 1, job 2, job 3, job 4, and these numbers are the cost. For example, if we assign person number 1 to do job number 1, we will be paying 9 rupees. Or if we assign person number 4 to do job number 2, we will be spending 6 rupees. So these are the costs. Okay, so the first step is that from each row, so these are the rows, this is row number 1, row number 2, row number 3, row number 4. From each row we have to identify the smallest number. So in this row 9, 2, 7, 8, the smallest number is 2. In this row 6, 4, 3, 7, the smallest number is 3. In this row 5, 8, 1, 8, the smallest number is 1. And in this row 7, 6, 9, 4, the smallest number is 4. Now we need to subtract from each element the smallest number. So for example, now we are going to subtract this 2 from 9. So we will get 7. Then we will subtract this 2 from this 2 and we will get 0. And we will subtract this 2 from this 7 and we will get 5. And then we subtract this 2 from 8 and we get 6. Similarly, for this row, we are going to subtract 3 from each number. So if you subtract 3 from 6, you will get 3. If you subtract 3 from 4, you will get 1, and so on. I hope you got the idea. So after doing this step, where we subtract the minimum number from each row, from each element of that row, we will get this matrix. So don't be confused by the term matrix. Matrix is simply another name of calling these numbers, because these numbers are in a form of table, 2-dimensional table. Therefore, I am using the word matrix. Okay, so now we have got this matrix. After getting this matrix, we have to do, so what we did in rows, now we have to do for columns. So for each column, so there are 4 columns again. This is the first column, this is the second column, this is the third column, and this is the fourth column. Now from each column we have to identify the smallest number. So the first column is 7, 3, 4, 3, smallest number is 3. Second column is 0, 1, 7, 2, smallest number is 0. Third column is 5, 0, 0, 5, smallest number is 0. And the last column is 6, 4, 7, 0. So the smallest number is 0. Okay, now we have to subtract these small numbers, smallest number from each column, from each element. So for example, we will subtract 3 from 7 and we will get 4. Now we will subtract 3 from 3, we will get 0. 3 from 4, we get 1. And 3 from 3, again we get 0. In all other 3 columns, we have to do the same thing again, but because the smallest number are 0 here, so if you subtract 0, you will get the same number. Therefore, we are not spending time on this. We are going to get same numbers because we are subtracting 0. Now we have got this matrix, and now we have to do allocation. Now allocation means you are going to decide which person is going to do which job. Whether person 1 is going to do job number 1 or job number 2 and job number 3 or job number 4. That is, we have to decide. And because this is an assignment problem, as you all know, as in assignment problem, one person can do only one job and one job is done by only one person. So now to do the allocation, we will start with the first row. So in this first row, we will check whether there are how many number of zeros are there. If there is only single 0, we can do the allocation. If there are more than 1 0, then we should not do the allocation. We should move to the next row. So here in the first row, there is only 1 0. So we will do the allocation. We will allocate, do the allocation. We will allocate person 1 to job number 2. Person 1 to job number 2. Now here we have 2 zeros in the second row. Therefore, we are not going to touch this. Now let's move to the third row. In the third row, there is only single zero. So we will do the allocation. What it means is that we have allocated person number 3. We have allocated person number 3, job number 3. So we have 3, 3. Okay. Now we will go to the fourth row. Fourth row right now has again two zeros. So we will not do the allocation. Now after doing allocation in these 2 rows, there is one more thing that we must do every time we do the allocation. So every time we do allocation here, we should cut all other numbers from the row of this allocation and the column of this allocation. Why are we doing this? Because once this person 1 has been assigned job number 2, it means that this person 1 cannot be assigned these values 4, 5, 6. Therefore, we cut them. Similarly, once job number 2 has been assigned to person number 1, this job cannot be assigned to any other person. Therefore, we have cut all the numbers. Similarly, because we had done the allocation here, we are going to cut the numbers in this row and the numbers in this column. So we'll do this. Now let's go to row number 2 again. So if now that we have come to row number 2 again, we see that this 0 has been cut. So we are only left with this 0, and therefore we will do the allocation. So we have done the allocation, which is the person number 2 is going to do job number 1. So 2, 1. Now we will come to the one more thing. So the moment we do the allocation here, we have to delete this 0. And now when we come to row number 4, and also we delete this because we will have to delete this entire row and this entire column. Now when we come to row number 4, we are left with only this 0. That means we will do the allocation. That means person number 4 is going to do job number 4. 4. Now the moment we have done the allocation, we will again go back to our original matrix. This is the original matrix, and we will highlight those places. So the first place was 1, 2, means first row, second column. So this 2, and then 2, 1, which means second row, first column. Second row, first column. So we will do the allocation here. And then the third place is 3, 3 and 4, 4. So 3, 3 and 4, 4. So this is the actual allocation that we have done. So now the person 1 will do job number 2, and we will have to spend 2 rupees. The person 2 will do job number 1, we will have to spend 6 rupees. The person 3 will do job number 3, we will have to spend 1 rupees. And person 4 will do job number 4, we will have to spend 4 rupees. So now we will do the total calculation. How much money are we going to spend? So 2 plus 6 plus 1 plus 4, which is equal to 2 plus 6, 8 plus 1, 9 plus 4, 13. So 13 is the total cost by Hungarian method. One more thing which I wanted to mention here is that in this particular problem, we could finally do all the allocations, because the numbers were getting cancelled out, and we were able to allocate in each row. Over the time, we were left with only single 0 in each row. But this may not happen in some problems. But those problems right now are out of scope for this video.